We are all ready. Welcome back on a second day. Yesterday was a relatively long day. A lot of information came your way from both Priyanku and myself. We have a lot of questions and some vague ideas how to address them, and we will start sort of proceeding, hopefully, towards sort of figuring out and learning and getting used to the ways how we actually analyze some of the language diversity and variation from typological point of view using machine learning methods. Today we will dedicate mostly to databases, because of course, in order to do this type of data-driven analysis or data-driven visualization of some sort of relationships between different linguistic units, dialects, languages, prosodic patterns, whatever we decide to analyze, we of course need good data. So we will talk a little bit today about the data, and hopefully this is we are very excited about the prospect that maybe by tonight we will have not one but two databases, which we source from you. That we are going to dedicate this afternoon session, the tutorial, to really do hands-on job and prepare the database, which we will then be able to analyze tomorrow and day after tomorrow. And maybe by the end of the week we will even get some new results. We'll see how it goes. As I said, we are very excited. It's going to require a lot of concentration. I would like to ask the online participants as well to join in the tutorial if they can, and also process the data. We will all do it. I will be guiding you. We'll show you what we want, and hopefully we will kind of reach some consensus and prepare some database. So I'm going to be talking about the databases a little bit from the sort of overview thing a little bit later today. But first thing, I will run you through some sort of examples and reviews of some machine learning based analysis. Priyanku has shown you yesterday some results of some sort of way of more standard phonetic analysis of tonal patterns and many other prosodic phenomena, also partly sort of machine learning driven, using all classifiers and sort of statistical modeling and things like that. And instead, I will today show you some results. We are not going to go to any details. Some sort of results, highlights of the phonetic prosodic typological analysis driven by the deep learning methods.
Hello, sir.
When I was a PhD student, my supervisor started writing my first conference papers and journal papers in particular, and my thesis itself, my supervisor,
You're right.
Dr. Fred Cummins, yes?
You're right. Now the video is there, but we could not see the video until now.
Okay.
Just now video has came back. Okay, thanks.
That's absolutely fine. So I'll just start the previous sentence again. So when I was a PhD student and started, my first attempt to write conference papers, journal papers, and then of course starting putting my PhD thesis together, my PhD supervisor, Fred Cummins from Dublin, told me that when you write a scientific text, we are not writing a detective story. We don't need to keep the reader in suspense. We don't have to put all of the ingredients in and then at the end as a surprise, or maybe less of a surprise, come with a sort of secret message. It's good to reiterate things. It's good to repeat, and we can sort of spill the beans. We can tell who is the murderer at the very beginning, ideally in the abstract, so that the reader knows what's coming, and she or he can, go, oh wow, this is how it might go. This is what it is for. So I'm going to do something a little bit similar, and I'm going to show you the results of our analysis today. I spill the beans. What can we do without really going into details? Yesterday we did some small introduction to the machine learning things. It might have been straightforward for some, maybe slightly more challenging for the others. But we are doing this, we are trying to do this sort of in this iterative way. So now I'll show you what can be done, so we can start thinking what type of analysis we can do. And these are only a few examples. I'm going to show you 3 or 4 examples. And then tomorrow, day after tomorrow, we will actually try to show you how it's done. So we know some basic ingredients, you will see the end, you'll know who the murderer is, and next we will hopefully try to find the path, how we actually found the culprit. So I will sort of talk first about 2 slides, about sort of the basic ingredients into, when we want to analyze speech using machine learning things. And I'll show you several examples, essentially. That's pretty much all. So what are the basic ingredients? So number 1 ingredient is the question. We want to have some question. We want to know some answer to some, ideally, phonetic, prosodic, linguistic question. How are different dialects distributed around some particular area? What are potentially relationships in some particular phonetic, prosodic aspect in between some languages spoken in the world? How are regionally varied realization of some particular pattern or something like that? Not every question can be addressed, as to my knowledge, with my level of imagination, not every question can be addressed by these type of methods. There are some questions which are better, some which are maybe more difficult. So of course, all of you are doing some particular work, all of you are driven by some questions, whether they are sort of practical questions, somebody told you to focus on that, or you have a burning passion to kind of find the answer to some particular scientific sort of mysteries, to solve some scientific mysteries. So of course, you have to then figure out the methodology, which is the right type of methodology for the given question. And of course, this methodology is not the right methodology for every possible question you might have. But maybe for some, it might work fine. Second, of course, we need a suitable data in order to address this question. So we need to have the data, which I'm going to use the term source of variation. I'm going to repeat it today a few times and throughout the course. So we need the data which contain which can serve as a source of variation of the phenomenon we want to investigate. This doesn't necessarily, there's nothing mysterious about that. When we want to investigate dialects, we have to have a database which is varied enough in an appropriate way in terms of dialectal speech. If we want to investigate tones, we need a database which is varied in terms of tonal realization. We want to investigate some gender-based differences between some realization of some particular speech patterns or phonetic patterns. Then we need a database which contains reasonable representation of all the genders you might be interested in. That type of a thing. If you want to look at how the age potentially determines some speech of the participants, maybe you are kind of thinking about kind of how the sound change, there might be some ongoing sound change or influence from some other dialect or some creolization, and you kind of think that older people sound different to the young people. Then again, source of variation is the age of the speaker. So you have to have the database which contains the reasonable variance along that particular dimension. And of course, then we need a technique, some particular methodology. We need some appropriate combination of sort of signal processing, in this particular case machine learning, and visualization techniques. It could be, of course, machine learning might not be appropriate method, so you might kind of use some statistical analysis, you might use whatever, random effect models or some more straightforward analysis or anything. Quantitative analysis, qualitative analysis, all of those things are possible. All of these 3 ingredients are interconnected, of course. As I was saying, the question you have to have, for the given question, you have to have the right type of database. For the database, you need the right type of technique. For the given technique, you might need right type of database. For example, sadly, for the machine learning exercises, we sort of need big databases. You know, we need a lot of data. If you want to look at some very narrow, small, interesting phenomenon, you might want to design some standard phonics database where you kind of create the variation along the very small dimension and in a very precise way. So you have sort of a relatively large number of samples which vary along some particular phonetic, phonological, prosodic dimension. And all of those things, I can kind of continue with all of these combinations, how the implications go. You know, I'm gonna now. This was all the theory essentially we had for this. So I'm gonna go now through several examples. So the first example is a data-driven typological clustering of world languages based purely on how they sound. This is something which Tukka has actually mostly done. That's one of the questions he was addressing in the last year or so. And so the question essentially is what kind of relationships among the languages in the world can be sort of unearthed from speech signal only. You know? If we are sometimes kind of, when we think about that, and I don't remember whether we have submitted a paper recently, whether we put it there, but one of the kind of ideas, images, metaphors we have for this is that imagine some sort of extraterrestrial landing on Earth. Knows nothing about linguistics, doesn't know how the earthly languages might work, structure, but hears different people making different sounds. And can that sort of completely uninformed, linguistically totally naive person, how would they cluster languages of the world? What patterns would they find? So for the database, of course, we want the world languages, so we need a database containing a lot of samples from a lot of languages. We have used this common Mozilla Common Voice database, which contains, it's a big database collected from sort of many languages around the world. I think there are like way more than 100, so not a huge amount, as a matter of fact. Way more than 100. For some languages there is very little material, so for some languages there is more. But and they connect, actually I said up to 1,000 samples because we sort of cropped it, but some languages contain many more than 1,000 samples. And yeah. Of course this database, as always, is not very representative when you look at the world. You know, it's very Europe-centric, of course. The European languages are way overrepresented, like way overrepresented. Almost, I don't know, up to 2/3 of the languages which are contained there are European languages. Indo-European languages are overrepresented. It's part of that. But of course, the Indian languages, at least the major ones, are well represented in the database. African languages are almost completely missing. South American languages are almost completely missing, native languages, but the Southeast Asia languages are sort of represented somewhat, to a lesser degree. Even Central Asian languages are represented, so it sort of depends. It's a little bit of hit and miss. It's an ongoing project. The new and new samples are being added. It's of course Mozilla. It's a corporate-owned database, but I think it's some sort of collaborative issue. So they gather whatever they can get their hands on. So the database is growing, and potentially, hopefully, not only in terms of the number of samples of English, but also hopefully in terms of number of languages and minority languages and all that. There is, as far as I remember, Tukka will know better, but there is essentially no Australian Aboriginal language represented in the database whatsoever. So there are these huge gaping holes in the thing. And the technique which we use to analyze this particular data is the combination of wave-to-vec representations and LID technology and linear discriminant analysis. The stuff I was talking about yesterday, not in very depth. We will go a little bit further to the depth in these things, but they are sort of what we were talking about yesterday. We take the recording, we run it through this particular type of representation transformation, wave-to-vec with kind of this context-dependent representation we create, then fine-tune it for language identification, and then we kind of look at what comes out. This is particular methodology which we will go hopefully to some sort of depth, and you will be able to hopefully on Thursday even, we are planning to analyze the database which we collect today using this technique. So keep fingers crossed. So now this is the result. I'm not gonna go through the process. Just, I don't know if you can see it actually very well, but this is a, here is a, this is a sort of dendrogram, this sort of circular dendrogram, you know, plotted, you know, these, they are the leaves, are the languages here, and the, you know, when the leaves are together or on the same branch, they are more related. When they are further, they are sort of less related based on this technique, right? This is purely, this tree here is completely data-driven. The zero linguistic knowledge would be put into that. It's purely based on the sound. The machine learning technique is completely agnostic to things like language family and the structures of the languages and morphological characteristics and what have you. It only has what it got from this type of machine learning processing. So I don't know whether you can see it very well, but the languages actually are lumped together, are organized in a kind of meaningful way, primarily based on geography, funny enough. So can anybody see those names here? Okay, from distance? No. Tuka doesn't need to see them. He actually created this picture. This is from our recently submitted paper with the Tuka, who is there, and Antti Suni, who is our very close collaborator. And in many ways, his contribution to all of this work is absolutely crucial. You know, every now and then I kind of try to think that which of the ideas which I'm talking about do not originally come from Antti. You know, he's very creative guy. So importantly, you can see that the languages are on this sort of circle, organized in sort of geographically. So here comes sort of Northern European languages. Here come Central, Eastern, and South European languages, mostly Slavic actually. Here comes North African, West Asian, and Central Asian languages, somehow lumped together from all the way from the sort of Persian and Arabic here, and even Mongolian and Georgian are somehow linked to that. So, funnily enough, these geographical links, even wider. Of course, Arabic spreads vast amount of the world, from Morocco all the way to Iraq, essentially. So it's a very big area. So that's sort of, you know, Arabic is both sort of African and Central Asian language in some sense. So, but you can see that these geographical links dominate this organization. Here is maybe the interesting corner for you. This is South Asian languages, primarily Indian languages, and the other sort of maybe some other Indo-Aryan and Dravidian languages spoken outside India. Here are the East and Southeast Asian languages, sort of Chinese, Vietnamese, those languages here. And here are several very small, unfortunately, database. That's one thing which we are really feeling sad. These are sub-Saharan African languages. There is only a handful of them, but they got lumped together anyway, you know. And this is a Mediterranean Europe. So these are mostly Romance languages. The leaves, actually, this is certainly you cannot see that because I can barely see that. We will share the slides with you. Priyanku is working on sort of some way of sharing. These presentations are humongous because we have all of the sounds and pictures involved, so they are like tens of megs. So we want to kind of a little bit make them smaller, maybe turn them to the PDFs. So then, but then we will be able to see all of these things in more detail. So these leaves here, as you can see, are colored by sort of language family and subfamily. Of course, if we colored it by kind of large language families, whatever 2/3 of those languages would be Indo-European, so it would be kind of boring. So for Indo-European languages, which as I said, like vastly overrepresented in this database, we get these subfamilies of the Indo-European languages. So these red ones here, the dark red ones, are actually Germanic languages. These lighter kind of orangey ones here are Slavic languages. These sort of peach color languages are sort of Romance languages. And here, these lighter peach color languages are the Indo-Aryan languages. And, well, yeah, that's why I think that comes from Indo-European. And of course, you can see that these Indo-European languages are sort of joined with the other non-Indo-European languages spoken in the area. So for the Indian sort of branch here, or this branch here, is sort of the South Asian Indian part. So you can see that, for example, you know, Telugu, Tamil, Malayalam are here, along with the other languages spoken in the area. You can see, for example, that it actually works quite neatly, because here this branch is actually sort of Eastern. Eastern Indian. There is a, sorry, this one. There is a Assamese next to Oriya language, Bengali, Nepali, and Santali, where Santali spoken in. And here is a sort of the, you know, Diveli and Telugu, Tamil, Malayalam, the sort of South Indian languages, and Urdu, Hindi. Unsurprisingly, there are recordings labeled as Urdu and Hindi. Unsurprisingly, they are by miles the nearest language in our database, by miles. We can, of course, have different visualization when we can see distances for different pairs, but they are much, well, there are no other two languages in the database are anywhere near that close. That doesn't surprise you, I guess. The one other thing is that what I want to show again, and then I need to go forward. I don't know what time is it actually, but it's fine. So these are sort of Northern and Central and Eastern European languages, and these green things here are Uralic languages. Uralic languages, it's a smallish sort of subfamily of languages with the, I guess there are sort of several Uralic languages spoken in Europe. A branch of them is Finno-Ugric languages, so Finnish, Hungarian, and Estonian are Finno-Ugric languages, and the other Finno-Ugric and other Uralic languages are spoken in Russia. I think it's one of the just about European side of the Ural Mountains. That's deemed to be sort of the original area where these languages sort of evolved, and then some of the peoples from that area migrated to Europe, and they split at some point. Some went north to the cold part of Europe, and they ended up being Finns and Estonians, and some went south and ended up being Hungarians. Of course, they had a very long and lively journey on that. I think that some ideas is that this sort of original split started, I'm not a linguist, but I have heard somewhere that, you know, started like 5,000 years ago. So that's been a long journey. Nevertheless, and even the split between Hungarians, which went south in Europe, and the Finns and Estonians, which went north in Europe, also happened a long time ago. That happened 3,000-4,000 years ago, if I understand it right. Nevertheless, in Europe, these three Uralic languages clustered together. Of course, Finnish and Estonian are still closely, almost mutually understandable languages. They are still relatively closely related. Hungarian is not mutually understandable at all. It's like lexically, it's almost completely different. Structurally, it's still quite similar. Morphologically, it's somewhat similar, but otherwise, they are sort of like they really needed some effort from the linguists to actually realize that they are related. I think that was actually one of those efforts by von Humboldt, which was almost the foundation of the entire field of topology, when the German scientists noticed that there are some strange people in Europe who sort of speak differently from the others, not like differently like the Germans and French would speak, but so that actually Indians speak more similar to us than these strangers. And they're kind of those Hungarians and Finns, and they were like, but actually, bizarrely enough, they're somewhat similar. So then when this sort of typology started, essentially. But they sort of structurally, linguistically close related kind of third cousins, like these are Eastern Western Mari, Moksha, Ezria, other languages, who are spoken in Russia. They are clustered with Russian and all the other East Slavic languages. Now, these are all, many of these, of course, people who are the minority language speakers in Russia are, of course, multilingual, at least bilingual. And maybe their means of daily communication might be Russian. So one can say that they have Russian accent in the Mari, or the other way we can say that the Mari has been vastly influenced, prosodically, at least phonotactically, phonetically, by the majority language. And this probably is the case in many other places. For example, Irish Irish and Welsh are actually clustered with English. Because again, the same situation. Most of those Irish and Welsh speakers would be bilingual in English, and they would simply, on average, sound a little bit like English even when they speak quite unrelated language. Mm-hmm. So this is a type of a tree we can achieve, and you can see that, it's kind of mesmerizing to watch. We spent like a year writing the paper, mostly because we were just going and checking all of these things and kind of could not believing and rerunning things because we couldn't believe that it works so well. So example 2, effects of age and gender on dialectal variation in a large corpus of spontaneous Finnish speech. So the question here is kind of straightforward. These are other those Tuukka's work actually. The question is, do younger people speak less dialect, the speech of Finnish young people somehow less dialectal than of the older people? And is there some gender difference in this type of, in terms of realization of dialects? So we use this so-called donate speech database of Finnish, which is a huge database. It's a kind of public project. It was started, and I think now maybe we will run the second round by our colleagues in Kielipankki, which is the language bank of Finland. That's the organization in charge of sort of maintaining the databases of Finnish textual and speech-based databases, and the state broadcaster in Finland, Yle. So the state broadcaster ran this campaign saying donate speech, and then the University of Helsinki created this interface where people can simply call in, essentially. And there were some prompts saying, tell us something about nature or tell us something about yourself. And they filled some metadata, and a lot of people responded. It was a big campaign. There were posters around the country and all that. Something maybe to think about in the area, or imagine all Indian database like that. That would be crazy, So we ended up with a lot of recordings. As I said, it's like 1,900 hours of speech, and I think this is a processed speech, if I understand right. So this is a transcribed thing. There's almost as much, again, yet, which has to be transcribed still, Somebody actually will manually transcribe, people listened to that and retyped it. It's a big project. Of course, the quality of the material varies. People called in, so some people had iPhones, some people called from the car, and some people have kids crying around and whatever, so it's varied. The metadata are completely voluntary, so we have to just trust them. On average, they are fine. Some people didn't want to publish all information about themselves, so there are gaps in metadata. You can imagine that this is a tough database to work. But it's so huge that we hope that the size of the database will somehow compensate for its shortcomings. And again, we use essentially the same technique for this analysis as before. And there is plenty of different results. You can very easily discern the Finnish dialect, for example, from the data. If you just lump all people from different areas together, the dialectal map, the dendrogram we can generate from that copies extremely well the sort of linguistic analyses and actually geography again. Geography of Finland and all that. It's again sort of uncanny how precisely you can reproduce the painstakingly gathered linguistic sort of relationships between different dialects. But this was actually something different. We looked at the way how potentially these sort of dialects realized by female and male speakers in the database, and how they are realized by sort of younger people, middle-aged people, and older-aged people. So we split the data because there is so much. We could split them to all of these categories and have a look. So this is not easy graph to read, but doesn't really hugely matter. Again, you will be able to look at it in detail, and you can have a look at the paper. This is very accessible paper, in my opinion. You can have a look at that. Many other sort of pictures and results presented there. But basically what we can see here that these are sort of the dots for different speakers, as it were, representation of different speakers. And these ellipsoids around there are kind of dialects, as it were, So this is one dialect, other dialect, etc. They are the same, I don't remember, 17 dialectal groups which are, or regional groups which are realized in Finland. All the things, these are rather subtle, but essentially if you look at the picture here, these are the older males. Each of these dialectal areas is much smaller compared to younger females. So you can see that the older males from the given area all sort of speak more or less alike, or more alike than the females from the same area, the younger females. So the dialects are sort of in this particular visualization sort of more dispersed. They are more different from each other, as it were. So the older people from the south of Finland sound more or less all the same. All the male in particular from northern Finland sound more or less the same, and they sound quite different from each other. While there is a bigger variation among the younger female from the south and the younger female from the north, and the differences between them are less pronounced. And you could see, if you're going to have time and study this in sort of a little bit more detail, you could see there's a trend. Even for the females, those little ellipsoids are becoming smaller and smaller and slightly more dispersed. And for males in general, ellipsoids are smaller and more dispersed. And again, with the age, it also shrinks and gets further apart. So it's the younger females which are the most sort of creative in some sense and most varied, most open to influences from the other dialects, and most sort of progressive in terms of sort of language change. And this agrees well with observations by Labov and from the big studies in the US, that it's actually younger female who are driving the sound change. They are the most creative, most progressive in terms of most imaginative in terms of how they speak. So this is another type of thing, given right type of data and right amount of data, which we can potentially look at using these techniques. The third example is a bit trickier. This is an example of regional effects on realization of Swedish word accent types, so tonal patterns. These tonal patterns, in Swedish, if I understand right, are something like the pitch accents in Japanese we were talking about. So Swedish is a little bit tonal language. They have some tonal contrast, but the tonal contrast is not sort of omnipresent. Not every syllable is tone bearing. It's actually rather rare. But some particular, so every noun in Swedish or something like that is assigned one of the type of the accents. So it's either is akut and sounds like, let's say, have a rising intonation, like dollar, or has a falling intonation, more or less, or some other type of intonation, like kronor. And the way how these type of templates, these two different accent type templates are realized, are different in different parts of Sweden. And the linguists identified 5 different, as if, tonal dialects, 5 different ways how the people realize these things. For example, Swedish is, by the way, official language in Finland as well. Only about 7% of people are sort of use Swedish as their preferred language, but it's still official part of Finland. It's spoken in sort of, this is Finland, by the way, this is Sweden, and it's spoken into sort of coastal areas of Finland. But when you listen to that, the Swedish spoken in Finland sort of pretty much converted to this Finnish prosody. Finnish is the syllable initial stress, has a fixed stress pattern on the first syllable because it's predictable, not super strong. So that's why it's quantity. So that's why it's something like syllable / mora time thing, and all the words start on a high and go down. So this zero type of the Swedish accent, of the Swedish word accent sort of template, that's primarily spoken in Finland, and that would be sort of just like dollar, kronor, no difference. And then then there are sort of these 2 subtypes, 1 and 2. The one has the acute accent falling, and the and the sort of single peak, the grave accent, and the 2 has the acute accent sort of rising, and the dip in the grave accent, accented words, and there is the subtypes A and B, which are differing in timing of the given peak. So some have the first syllable, some have it a little bit later. So this is sort of theoretically unearthed sort of dialect. Interestingly for us, although what type of kind of tone the dialect you speak as a Swedish speaker is sort of kind of a little bit related to the area, but there are a lot of exceptions. As we were talking about here, you know, like people were moved from one place to the other or moved and all that. So it's sort of, they can vary from the settlement to settlement, even within the same area. So this is, of course, there is a pattern, but there are many exceptions. So these are different types. You can see that there are this triangle type here, or you know, these type of type marked by crosses is spoken all the way down here, and even in this island here, and it's all sort of a little bit mixed up. So what we were interested in is this sort of language, is this sort of linguistically, we have a database, and for each particular area, for each particular recording site, some linguists said that in this particular village, this is the accent type they use. So we were interested in, is it sort of, do the recordings kind of corroborate more this accent type, or are they more related to regional variation? So do people speak more like the linguist would tell them, or do people speak more like the neighbors, essentially? So we just, again, this was a different type of methodology. This is WaveNet embeddings. I will maybe talk about that on Thursday a little bit. But this is actually the method which uses a generative sort of synthesis-like approach and extract the information through some sort of conditioning embeddings. Don't worry, we'll cover that. So it's a different approach than this sort of analyze, the Autoveg is sort of purely analysis-based and sort of kind of classifier-based technique, while this is a generative-based technique. So we create a synthesizer and look at the guts of the synthesizer, how it represents different variations. Advantage of that is that we can feed only prosody here. So this particular method did not use any segmental information, purely prosodic information. Purely F0 and intensity, as a matter of fact. Nothing else. And we use this sort of subset of this kind of rather big Swedish language database, which was we used something like, it was a word list actually, which we used. We analyzed something like 25,000 words or something like that from 104 locations in the Swedish-speaking areas in Sweden and Finland, essentially. And the results are like this. So this is a dendrogram. Again, don't worry. Again, there is a link to the paper. It's a rather older, actually, work. Link to the paper here. And you can essentially see that, you know, this is all the possible combinations of some sort of geographic area in Sweden and the accent type. So the accent type 0 is only spoken in Finland and Åland, which is this island halfway between Finland and Sweden. But there are some accent type 1B is, for example, spoken in 2 areas. 2B is spoken in 3 areas. So we found all the combinations and wanted to see whether this will sort of be lumped geographically. So will we get the split based on geography, or will we get the split based on the accent type? And what we got is something in between. It's actually scaringly perfect, the splitting. We quadruple checked the methodology, whether we didn't do something wrong, because it's too perfect. But we are quite confident it works. And you can see that actually the recordings or the patterns were split primarily based on this major accent type 0, 1, and 2. First split is between 0, this non-distinguished accent types, and these more melodic ones, and then the melodic between 1 and 2. But within these groups, within these sort of major accent types, the things are organized geographically. So we don't have 1A and 1B branches, but we have the Svealand and Götaland branch. Here we don't have 2A and 2B branches, but we have Svealand, Norrland, and Götaland. These are the regionals. So it's something in between. So the way how these prosodic patterns are realized is something between so the major accent type are distinguishable, but within the major accent types, geography dominates. So you speak a little bit like the linguist tells you, and a little bit like your neighbor. Last example is the data-driven analysis of some Assamese recordings, which were provided to us kindly by Lina and Priyanku. So, and essentially this is somewhat similar to the world languages. So the question is how related might be the different dialects of Assam, of Assamese. We got sort of recording of sample speech, the north wind and the sun, unsurprisingly, from different locations in Assam. Ask Lina for the details. I just got we just analyzed what we got. And when we use the same analysis as for the world languages, so Vahtu-Vek and some other things, which the methodology which we will use later. So this is again, we have recordings from about 60 sites around, and from each site something like 10-ish speakers more or less, and kind of males and females reasonably well balanced and all that. And we chopped those recordings based on sentences and then performed the analysis. That's what we are planning to do, by the way, with your data as well, later today and on tomorrow and on Thursday. And now I'm gonna show you dendrograms mostly. And I don't know, we've been with Tuukka and myself, we've been trying to get to familiarize ourselves with the map of Assam, but I'm still quite lost in terms of the names. So whenever we generate the dendrogram, we have no clue whether it's good. So we take Google Maps and check like which of these these towns are indicated to be close. So I go and ask Google Maps to find me the driving directions from one town to the other and check how many hours it would take, you know. It's very frustrating when you get these sort of predicted very close and then the driving distance is 14 hours or something like that, you know. I guess in Nagaland it would be sort of still quite okay, but yeah. So this is the dendrogram we got. I don't know, can you see these labels here? I let you, at least the sort of Assamese people and people who know this area well, to check whether it makes sense. First of all, let's have a look at this split here. This is the major split between the data. So I would have hoped that these are primarily sort of lower Assamese locations. What is it? Dhubri, Barpeta, Darapur, Nalbari, and things like that. That they should be, hopefully, if all goes well, mostly lower Assamese locations. And these from up to here. And these would be probably more upper Assamese. Central and upper, yeah. Now, you can see that in these sort of major split 1, 2, 3, 4, 5. So there's a first split, then this is almost identical sort of there, and this one first split, this sort of lower Assamese or Western Assamese locations are split to 2 subgroups, and these are split to 3 subgroups, and these subgroups are sort of colored. And we can put those colors on the map of Assam here. So these are there should be 5 colors. 1, 2, 3. Oh no, we only have 4 colors. So it looks that these are 4 colors, so it's split somewhere else. But you can see that it actually makes sort of geographical sense how this thing goes. There is one notable exception here. That's the town of, which one is it? Yalakipur. And there is a little bit of a mistake in metadata in the date, because there are the 2 towns in Assam which have almost the same name. And when we were processing them, I think we dropped something, so this actually has the data, also contains data from some other part. So even this kind of head-scratching outlier has this type of explanation. This is a very instrumental explanation. Whenever you see something too good to be true, or really too bad to be true, investigate further. Very often you find some reasons for that. For us, sort of kind of people who deal with behavioral data and this messy data, too good is probably even more scary than too bad. Too good means that, oh, there might be something. I'll talk about that actually, try to remind me. I'm going to talk about database. I'll give you an example of a too good thing. So this data, these results, are based on these wave-to-wake embeddings, which we don't know exactly what they contain, but certainly they contain some prosodic information, but they also contain some segmental information, maybe some overall, the forming characteristics, some phonotactical information maybe, what things are, some rhythmic information, all of these things. We don't know really precisely what drives these distinctions. So I kind of thought that, that when I was showing you the Swedish thing, the Swedish accents, we have this other method which you can sort of really pinpoint and make sure that you are really only talking about the F0 and intensity patterns. So yesterday I used that to the same database. This is unfortunately very small database for this type of analysis. So advantages that I trained it in like 15 minutes or 20 minutes, the thing, and then plotted something. So I trained it 3 times. I have 3 takes on that. So, but I didn't have time to kind of put it on a map. So I don't really know whether it works. So I leave it to you. So this is the same data with the different type of method, purely on prosody. And this is the first dendrogram. Does it make any sense to you? It might not make any sense. I know because I checked locally, so there are sort of massive discrepancies. But whether there is any hint of anything good, I can show you a second take on it and a third take on it. So you can see that every time I train it's slightly different. This is a sort of one thing that when we use these pre-trained things, then we get the process is sort of deterministic. Whenever we run it again, you get exactly the same thing. While when we train our own models, then every training yields a different things. So I'm not sure whether this is any good at all. Now remember, this is purely on prosody. That means it's really relatively little data. And of course, also the recordings, we didn't prune them. There are a lot of hesitations and things like that. So some of these similarities might be driven purely by that, for that area, arbitrarily, the people which were recorded were slightly more hesitant or whatever. So this might dominate the things. And as I said, like having 5 speakers from each area or 10 speakers, for this type of method is very, very little. But we will try it also to train it on the database we create today, and we see how it goes. So yes, so this is what I wanted to show you now. So let's now take a little break. Do you have any questions, of course? So when I trained this particular model, I also provided the gender and the given sentence label. So I trained, we will talk about this in more detail on Thursday, but I trained sort of 2 different vector representations. One is the vector representation, or embedding, we refer to it. One is a vector representation of these recording sites. And in parallel, I gave the synthesizer the knowledge that this comes from a male or this comes from a female, because the pitch, is kind of big different, and which of the 5 or 10 sentences this type of a thing comes from. So it got this type of a context. And it sort of stores these different information then in 2 different vector representations. And the idea is that, we have one which is of interest, this dialectal thing, and the other one which we call normalization embedding. This is the one which actually doesn't interest us, it's a source of variation which doesn't interest us for this particular research, So we hope that all the information the synthesizer needs in order to do that goes there, and only keeps the relevant information in the other one. By the way, this is because the sentences are so long. Maybe if we process the database further and had something like word, for example, level annotations, so we would give it the word identity, so the synthesizer would kind of concentrate on the smaller chunks, like with the Swedish thing, smaller chunks where it takes the, different, that doesn't have to kind of memorize the entire sentence as it were, but the smaller bits, then maybe we would get sort of cleaner results. We'll see how it goes. By the way, this technique works also for these sort of more localized analyses. Jeanne, who is here, she remembered that a couple of years ago in Helsinki, we actually used a very small data and analyzed some tonal realization in, actually Angami, was a standard Angami spoken in 3 different locations. No? It was in Jotsoma, Kigwema and Kohima. And we got some meaningful results in terms of how tones are realized in these different areas. And it was a very small database. Again, we had like 5, 6 recordings for each or something, and maybe only 2 or 3 from Kohima. But it's so if you have a very targeted question, this technique might yield very good results. These are maybe a little bit too broad question for this type of a technique. Mm-hmm.